Hello and welcome to this brief tutorial on using FastX to connect to CHPC resources. FastX is used to connect to Linux resources graphically if you want to use a desktop environment or just connect to a terminal through the graphical interface. It makes multitasking much simpler as you can have a desktop environment and have multiple windows open at the same time instead of connecting to multiple SSH sessions, for instance, or trying to use a program that lets you multitask on just a single terminal emulator. And it can also be used for persistent sessions, which is great if you work from home. So if you normally start working on a project at work and then say you have to go home, you can pick up right where you left off on your home computer without having to restart any of your programs or reset anything. So it works very well for anything that might run for a long time, though you do need to respect the same usage policies as the other interactive nodes. But if you're running something like an IDE or you need to use MATLAB to generate some plots, it's very nice to have something that you can just start and let run and not have to worry about. CHPC has a site license for FastX2, which means it's installed on many of our interactive nodes. However, as I mentioned before, you do need to respect the usage policies, and if you have something that's computationally intensive, you will need to use a compute node. If you're doing graphical work, the Frisco nodes are recommended instead of a normal interactive node like the Kingspeak interactive nodes, because all of the Frisco nodes have graphics cards. And this was not true previously. In the past, only a few of the Frisco nodes had dedicated graphics capabilities, had graphics cards, but now all of them do, though the number of cores and the amount of memory that each node has does differ. At the time this video was recorded, there are Frisco 1 through Frisco 8, so Frisco 1, Frisco 2, Frisco 3, so on. And all of them, as I mentioned, have their own graphics cards, so you can utilize hardware acceleration and any programs that might need more complicated graphics libraries. They'll run much more smoothly and much faster on the Frisco nodes rather than any other interactive node. There's documentation on the Center for High Performance Computing website, chpc.utah.edu, that covers the most recent information about the Frisco nodes. You can find this page by either just searching for Frisco or going to Documentation Frisco Nodes. This page covers a lot of the details about each node, such as how many cores they have and how much memory, and also mentions FastX and the different policies that are in place on the nodes themselves. There's also documentation about the FastX program itself on CHPC's website, and that mentions some problems that people have had and different ways to connect. It mentions the web browser method of connecting, which I'm not going to cover in this video. However, you can use that. It's generally not as great for heavy graphical tasks, but it works great if you need to connect to any resources and can't install software on your own computer. There's been a slight change to the way you install the FastX desktop client on all operating systems. So I'm going to go to an interactive node here, kingspeak.chpc.utah.edu:3000. And instead of having a link to download the client here, you have to log in first. So I'll log in with my university ID and password. And now there's a link in the bottom right hand corner here that will take me to a page where I can download the software for my operating system. So again, there's just one additional step here. You'll need to log in when you reach the FastX web interface before you can download the software. To download the desktop client, you'll want to connect to an interactive node at port 3000 in your web browser. So here I'm going to connect to kingspeak.chpc.utah.edu:3000 and click the drop-down menu to download the Linux client. Once you've downloaded the archive, you'll want to use the tar command to move all of the files it contains into their own directory. So here I run the command tar xzvf and then the archive. I'm going to change directories to that location that it just created, and if I try to run the application now with the symbolic link app run, you'll see that I am missing a shared object file. So this is defined by your LD library path, and depending on where you install this package, you will need to specify the library path that works with the pre-installed libraries and the libraries that FastX includes itself in the lib directory of the FastX directory that I'm in right now. If you don't know how to change your library path, please consult some documentation before trying to do so, as this has implications for your system and other packages on it, and if you don't do it correctly, you could break some of the other software on your computer. I'm going to, since I'm using bash, run the export ld underscore library underscore path equals the library path of my system, which in my case is lib64, and typically this is already defined, but it is not on my computer, so you'll probably want to run ld underscore library path equals $ld underscore library path : and then the library location for FastX itself. And it's generally not recommended to use relative paths in this, but just for demonstration purposes I'm going to, so I'm just going to use ./lib. And now when I run the application again, I should be able to access those object files. Connect to an interactive node on port 3000 in your web browser. Here I'm going to connect to kingspeak.chpc.utah.edu:3000. To download the desktop client, you'll want to click on the link that says looking for the desktop client and choose FastX for Windows. Save this file, and once it's downloaded, you can double click it to run the wizard. So I'll double click this and approve the changes to my system. And this should launch the installation wizard for me. You'll need to read the license agreement and accept it. So once you've read through this, you can install the program. And when this finishes running, you can just open FastX from the start menu. Navigate to an interactive node in your web browser on port 3000. So here I'm going to connect to kingspeak.chpc.utah.edu:3000. On this page, you'll want to click the link that says looking for the desktop client and choose FastX for Mac. This will go into your downloads, and once it's ready, you can just open it. So I can just launch it directly from here. I want to accept this, and it should start up. However, this solution is not permanent, and if you'd like to make it permanent and make it easier to find the application, you can just copy this into the applications directory on your Mac. Once you've done this, you should be able to find it in your other software. When you first open FastX, you will see this blank page and you won't have any connections established. So to create a session, you'll want to click the plus button in the top right hand corner and choose SSH. FastX operates over SSH. Here you can specify a name, which is whatever you want it to be. It's just an identifier for this particular connection. So I'm going to choose Frisco1. And you have to specify the host name. So it would be frisco1.chpc.utah.edu. The port will always be 22, and you'll want to enter in your university ID as the username. If you get a message about SSH keys, type yes and continue. You'll need to sign in with your campus credentials, the same password you might use to log into UMail. And you'll be connected to the node. To start a session, you'll want to click the plus button in the top right hand corner and choose which software you want to run. This is typically a command that starts a window manager, or in this case just a terminal. This is xterm, and this works just like SSH might. So you can run any Linux commands from here. I'm going to reuse part of an older video produced by Albert Lund for the graphical part of the FastX usage, because it mentions virtual GL and some problems you might run into when trying to use the graphical capabilities on any nodes. There are some things that are out of date in this segment, namely he mentions Frisco 5 and Frisco 6 having graphics cards, but again, all Frisco nodes now have graphics cards, so you can use any of the nodes for more graphically intensive work at this point. But beyond that, everything still holds, and it's a great reference for using graphical software and desktop environments through FastX.
First, we're going to show just the simple command xeyes. So you see we have xeyes here. It's maybe a little laggy at the moment, but that's okay. This is just like any other X terminal session, so you can do an ls or any other command that you would want to execute. But I'm going to choose Mercury, which is a molecule viewer provided by the Cambridge Structural Database Center. So I access that by doing module load CSD and then typing in Mercury. Now the reason I wanted to use Mercury is because it has a little quirk involved with it, which is that when you load it initially, this is a molecule viewer, so you should be able to view the molecule in this window right here, but it's not actually showing me anything. And the reason for this is because of the style of OpenGL rendering that this software uses. So really what you need to use is a special program called VGL Run, which is installed on all of the Frisco Peaks nodes. So you type in VGL Run followed by Mercury, which will run Mercury using virtual GL, which is what VGL Run is. So if we wait a second for it to come up, you can see that it's actually rendering something here. And now we can see that I have my molecule being rendered, which is what we expect. So if you use a software that does OpenGL rendering, and you find that it's not rendering properly, then you should try using VGL Run on Frisco 5 or Frisco 6. So next I'm going to show you how to use the desktop environment, because it's a little bit different and there's some things that you need to be aware of there. So I'm going to exit out of this. This is the clean way of exiting, and if you exit a session, then that's the way I recommend you do it. If we come down here and look at the suggestions, we have 3 desktop managers. We have XFCE, KDE, and GNOME. So you can use GNOME or you can use KDE, but at CHPC we don't recommend this. GNOME has an issue where you can only really have one session open at a time. So if you open multiple GNOME sessions across your different servers, then that could be a problem. The other thing with GNOME and both KDE is that they're heavier duty. So we recommend that users use XFCE because XFCE is much more lightweight, and it also has advantages with respect to being able to open multiple sessions in multiple places. So the question is, why would you want to use a desktop environment? And the number one reason that you would want to use that is so that you can have multiple windows open at the same time. So I personally like to have several terminal windows open at the same time. Sometimes I like to have other things open. For example, I like to do my software development on a desktop, and so I'll run Eclipse on my desktop environment. And so you can imagine that having a full desktop environment garners certain benefits that are useful. Now, when you open up your desktop session, there is just this window, so there are different things that you can do here in this little menu that you can access by just hovering near the top of your window. This pause button will pause the session for you, just like in the Session Manager window. This button, which I clicked earlier, will toggle resize mode, so you can resize the desktop window to whatever size, and the desktop will automatically adjust that size. This one right here is the full screen mode, which is useful if you just have a single monitor. I have multi-monitor set up, so it's easier if you use the resize mode and split across this. This adjusts your speed settings, which is kind of hit or miss. You can use this if you have problems with your connection, but I haven't had a need to use it. And then finally we have a session sharing button, which I'm not going to go over. So to demonstrate the persistent feature, I'm going to type in a thing here, and then I'm going to click the pause button, and then I'm going to disconnect completely from Frisco 5. And if I double click this guy, put in my password, you can see that my XFCE window is still open, and if I click play, you can see that the session is exactly where I left off. So if you like to work from home, this is the number one best thing that you could be using at CHPC right now for cutting off your work and getting right back into it when you get home.
I hope this video was helpful. If you have any questions or you'd like to suggest a topic for a future video, you can send an email to issues@chpc.utah.edu, call us, or stop by our offices in INSCC 405. Thanks for watching.